Hello everyone, today I want to explain about the amines. Amines are ammonia derivatives. So, what is the general formula for amines? That is RNH2. Otherwise, we can write aryl group NH2. R meaning what is that here? Alkyl group CN H2N plus 1. So, and this NH2 group. So, don't confuse. This is alkyl group. Therefore, we can write general formula. What is that? CN H2N plus 1 and NH2 group. Then totally, this is a representation of aliphatic amines general formula. Aromatic means any one aryl group that may be substituted aryl group or normal aryl group. Then these are which one? Ammonia derivative. In ammonia, how many hydrogens are there? Three hydrogens are present. One hydrogens are replaced by alkyl group, then we will get a different type of amine. Therefore, classification of amine in that primary amine. Primary amine mean what is that? RNH2. This is called primary amine group. Then primary amine group mean one of the example I will take. This is a CH3NH2. Otherwise, in cyclic, if I take, then this is cyclohexanamine. This is also primary amine. I will take one aromatic amine. Then this is also which one? A primary amine. Then come to the secondary amine. Secondary amine meaning what is that? In ammonia, two hydrogens are replaced by two alkyl group. Example here CH3 twice NH. If you consider any other aromatic or aliphatic also, this is cyclic and here NHCH3. And this aromatic, if you consider here NH, any ethyl group consider. ET mean what is that? Ethyl group. Then these are secondary amine. Then tertiary amine meaning what is that? Uh, CH3, how many times? 3 times. And all hydrogens are replaced. But keep in mind, this is CH3, CH3, CH3. This is what you call this carbon is called tertiary carbon. But if you write here NH2, this is not the tertiary amine. This is called which one? Primary amine. Because here what is there? NH2 group. NH2 group is there mean what you call that is primary amine. This is a special, not actually special, but students generally confuse here. Tertiary carbon is there mean tertiary amine. Not like this. NH2 group in primary, NH means secondary, N mean tertiary. That is primary amine only. Now what is the given this one? Next one, tertiary amine. According to this tertiary amine, already completed. No? Then quaternary amine. Quaternary amine meaning. What is a quaternary amine? Ammonium ion type. This is a in ammonia. Another extra group is there. It means NH4 is called ammonium ion. Similarly here, this may be one is methyl group, another is ethyl group, another is propyl group, another is isopropyl group. Like this, different groups are present, meaning this is called quaternary ammonium salt. Now you, after understanding all this, you decide that what is the type of this amine. Then primary or secondary or tertiary mean already I told that NH2 group mean primary, NH is there, therefore this is which one? A secondary amine. Similarly, if I write like this, then N only is there. That's why this is a cyclic, but it is a tertiary amine. This is which one? Secondary amine. I hope you understood what are the primary, secondary, tertiary, and quaternary ammonium salt. One of the quaternary extra example I will give you that, then you will understand exactly. This is called pyridine. On this we have anyone ethyl or propyl group, anyone. Then on the nitrogen, how many bonds are there? One, two, three, four bonds are there. Four bonds are there mean plus. Along with this, any Br minus Cl minus is there mean this is called quaternary ammonium salt. So I hope you understood this classification. So next one topic is the nomenclature of amine. Which nomenclature I am discussing now? Common names. How to write this common name in? This is already we know this is a amine representation. Then this is a alkyl group and this is a amines. Therefore alkyl amine is a common name. Sometime we will use di, tri and tetra like this. Generally tetra also very rare to use because maximum we'll use tri only in this. Quaternary time we will use a tetra. So these are the alkyl group we are using to indicate the similar or identical substituent. These are the prefixes. Prefixes used for identical substituent. That time only this is di, tri, tetra prefixes we are using. So already I indicated which type of these amines, primary, secondary, tertiary like this. So the first one given example is, so what is the first one? This is ethyl group. Therefore it is called ethyl amine. Then this is called 1, 2, 3, 4. I am not giving IUPAC name because common name. This is called iso group. What do you call this? Iso. But total how many carbons are there? So we have 1, 2, 3, 4, 5. Therefore it is called how many times? 2 times is there. So 2 time in di. Di is a prefix we are using for to indicate an identical substituent. Di isopentyl. Diisopentyl. Next, what is that? Amine. Next one. Here we have a tertiary amine. Here this is a methyl group. Here these are ethyl group. Alphabetical order, which will become first? Ethyl. But di is not considered in the alphabetical order prefix. Therefore, diethyl. And this is methyl also is not amine. Dimethyl diethyl methyl amine. So this is a ethyl group, this is a methyl group. But how many time here? 2 time is there. Next one, this is a quaternary amine. In this quaternary amine, this is a how many time? 4 time is it. But what is the name? 1, 2, 3, 4 time is there. That's what it is called. 4 time in what we can use the tetra. This is a identical substituent. How many time? 4 time. But name is called butyl, tetrabutyl. Ammonium. What do you call this? Is ammonium. And chloride is there. That's why space chloride. Tetrabutyl ammonium chloride. Then next one, this is a tertiary amine. But in this tertiary amine, what we can write? Alphabetical order. This is a cyclohexyl group. Therefore, cyclohexyl and dimethyl amine. Cyclo in alphabetical order is considered. That's why cyclohexyl dimethyl amine. Next one, what is that? Is a primary amine. This group is called benzyl. Therefore, this is called benzyl amine. Next one, these are the two phenyl groups. Therefore, how many times are there? Two times. To indicate the identical substance, we can use a di for two identical substance. Diphenyl amine. Next, NH2 group as amino group. Meaning what is it? NH2 group is NH2 group as a substituent. It means other than this some any other superior functional group are present, that time we have to use amino is a prefix name. So substituent meaning what is that here? Prefix. Its prefix name what is that? Amino. What do you call this? Amino. Then here we have all these are the example. In the first example, so already I mentioned here primary, secondary, tertiary like this, what are their respective. NH2 mean primary, NH means secondary, and N mean tertiary. N plus is that quaternary. Then we have one given compound. Then numbering start from the clockwise like this from NH2 group to double bond or double bond to NH2 group. Then always when you give the numbering on the principal carbon chain, then principal group should get the lowest number. But this is a principal carbon chain. If you start from here, so 1, 2, 3, then double bond getting the second number and NH to get the first number. But if you start from here, then which will be get there? This is 1, 2, 3. Therefore, the correct representation is a 1, 2, 3. Therefore, it is called 3 amino. 3 amino cyclopentene. Cyclopentene. This is common name, not as a IUPAC name only considered here. When there is no common name, that time you can write as a IUPAC name. But in such case, for example, now here we have NH2 group and COH group. Then COH is the first priority group than the NH2 group. Therefore, we will get the number here 1, here 2, here 3, here the 4. Functional group next carbon is called alpha carbon, second carbon. This is a beta carbon and this is called gamma carbon. Therefore, according to this common name, we can write gamma amino butyric acid. In case IUPAC name type if you want, then it is called 4 amino butanoic acid. Next, coming to the next example, then we have here OH group and NH2 group. In these two, which is a superior group? Hydroxy group is a superior than the or priority order respectively, according to use the word priority order, meaning a hydroxy group is the first priority than the NH2 group. Therefore, this is a 1, this is a 2, this is a 3. But keep in mind this OH group and NH2 group, this is away, dotted line mean away, dark line mean what is that? Nearer to the observer. So opposite is there, that's why this is called trans. What do you call this word? Trans to the cyclic system. 3 amino, 3 amino cyclo, what do you call? 6 means cyclohexanol, OL, cyclohexanol, OL. Next, coming to the next example, here we have amine group, we have the carboxylic group. Carboxylic group, first priority, therefore 1, this is 1, this is a 2, this is a 3, this is a 4. Then we can say common name respect to 1, 4 positions are para position, therefore para amino benzoic acid. Para amino benzoic acid. Next one. Coming to the next example, we have a hydroxy group and amine group. Hydroxy is superior than the amine group. Therefore, 1, 2, 3, 4, 5, 6. But on the nitrogen, what we have? Some alkyl groups are there. That time, secondary tertiary amine respective, keep in mind. When secondary tertiary amines are there, that name is classifying the nitrogen atom together with its alkyl group. So keep in mind, larger alkyl group considered the parent chain and smaller groups are considered the substituent. So now on this nitrogen, keep in mind, on this nitrogen, two methyl groups are there and one alkyl group chain is there. So larger chain is considered the principal carbon chain and smaller are considered the substituent. So secondary tertiary is there on the nitrogen. Any alkyl groups are present mean larger consider the principal carbon and smaller consider the substituent. This is very important, you have to remember. Therefore, now the name will be, what is the name? So third position we have, sorry, third position we have, how many two time methyl is there? Third dimethyl. Third, dimethyl amino. Now, amino is a substituent. This is the substituent. So, this substituent was the dimethyl amino. At which position? Third position. So, 3-dimethyl amino hexane 1-ol. This is a IUPAC name actually. Now, if you come to the next example, this is also which one? A tertiary amine. Then larger one considers the larger alkyl group chain considers the principal chain, smaller one considers the substituent. Then according to this, when more than one functional groups are present, then this is a keto group as a functional group and amine also functional group. Therefore, according to this numbering 1, 2, 3 and this is a 4. Fourth position we have this substituent. Therefore, it is called 4. This we can, now I want to little change because already methyl we took, that's why little I want to change. What is the change? This I will consider 2 and this is a CH3. Then now methyl and ethyl is there. So ethyl is first, that's why I can write ethyl and next methyl amino, close the bracket, cyclohexanone, because this is a ketone. On is there mean ketone. So this is a IUPAC name only for this compound. Now aromatic amines. Aromatic amines and heterocyclic amines are generally known by historical names. For example, phenylamine. This is called phenyl group. This is amine. Is called aniline. So we can write this is as a aniline. This is actually which one? Historical name, or that is considered as a common name, but also IUPAC accepted name this is. And remaining aromatic amines are known as a this aniline derivative. So these are called derivative of anilines. Remaining are called aniline derivatives. So what is an IUPAC or maybe common name considered? So it is called, this is a functional group now, aniline NH2 group. Then this is called ethyl group. Therefore, at which position is the first position? This is which one? Second position. Therefore, we can say this is 2-ethyl aniline. Next, if you consider this one, in this, what is there here? This is the first, sorry, here not, here 1, here 2, here 3, here 4. Fourth position is there. Therefore, it is called 4-methyl, 4-methyl aniline. Next one, it also known as common name purpose. This is called para-toluidine. This is called ortho 1-2 position, ortho-ethyl aniline. If you want one more example also, I will give you here. That is, this is represented as 2 time ethyl. This is ethyl group, this is ethyl group. Then this is amine. It means totally this is called alanine group. On this, what is there? We have two ethyl group. Therefore, N, because we are not giving number to the heteroatom for the normal aliphatic and aromatic amine. Only for heterocyclic nitrogen we are giving the number, not for the normal one. Therefore, N, how many times are there? 2 times. That is diethyl. 2 time ethyl group present on the nitrogen, and this whole group what you know, that is aniline. N diethyl aniline. Now, N heterocycles. It means nitrogen present in the ring as a heteroatom. That's why it is called N heterocycles. When heteroatom is present in the ring, so heteroatom usually assign the position number is 1. So this is very important for the next explanation. You have to remember heteroatom position is assigned generally 1. So now its name is aziridine. This is called pyrrole. These are the some common names. This is called pyrrolidine. Heterocyclic nomenclature rules are somewhat different, so these are the common names. And next, this is nitrogen atom assigned as the first number. That's what it is called first methyl, first position methyl pyrrolidine. What do you call this is pyrrolidine. This is pyrrolidine. So first position methyl is instead of hydrogen, therefore it is called 1-methyl pyrrolidine, or simply it is called N-methyl pyrrolidine. Sorry, one L only. Next, if you consider this one, this group is known as imidazole. What do you call this is imidazole. So here numbering start from which nitrogen atom, that is I mentioned here. So this is useful for the any other reaction purpose or to indication purpose. This is useful. So this numbering method you have to remember for competitive level. Normally not required that much. So here what is there? 1, 2, 3, 4, 5. This is a way of numbering for this imidazole group. Then next one. This is another heterocyclic compound. So this is somewhat important. That's why I forgot. Maybe that's why I'm writing now here. Its name is called indole. So these are which are frequently used in the competitive example that I am writing here now. And this is called pyridine. And this is the first number, second number means this is called 2-methyl pyridine. Next one, this is called piperidine. Next one, it is called, what do you call? Pyrimidine. Generally, this pyrimidine present in the in DNA, nitrogen bases, uracil, thiamine, like this. These are pyrimidine. Another one is a purine. This purine present in the DNA as a adenine guanine. When substances are little change, mean they convert into adenine guanine. So basic structure for cytosine, thiamine, uracil is this pyrimidine, and the basic structure for the adenine and guanine is this one. So keep in mind, in this one, some are the aromatic. So what are the aromatic mean? That I will represent this aromatic. And next one aromatic, which one? Totally what is required that you keep in mind. So in this one, 6 pi electron system required. So here 6 pi electron system is there. That's why pyrrole is the aromatic. And next one, imidazole group also aromatic because here 6 pi electron system is there. How it is 6 pi electron system in this is a 1, 2 electron, here 2 electron, and here this 2 electron, total 6. But this electron is not involved because which are involved in the delocalization, that is counted here. So this is aromatic. And next, pyridine. In pyridine also we have here lone pair, but this pi bond only involved 1, 2, 3. 3 pi bonds are involved. So 6 pi electron system aromatic this is. Next one, automatically this outside sign, this is also 6 pi electron system aromatic because useful for the competitive exam, that purpose I am writing here. And this pyrimidine also 6 pi electron system. These lone pairs are not considered here, only which one consider this pi bond, 1, 2, 3 pi bonds. Next, each individual rings, this is 6 pi electron, this is 6 pi electron, overall how much, 6 pi electron each ring, but overall how many in 6 member ring, 6 electrons are there, and outside here 5 member ring, lone pair 2 and this pi bond, so totally 10 pi electron system overall. So this is also 10 also aromatic, that's why this is aromatic ring. Remaining are non-aromatic. So which is non-aromatic? Now I am representing, this is a non-aromatic, non-aromatic, non-aromatic. Next, here non-aromatic. Remaining are aromatic. Now, IUPAC names for amines. So, what are the rules? Generally, a long carbon chain, long continuous carbon chain is a parent chain, and nitrogen is a prefix. When nitrogen is prefix used for substituent on nitrogen atom for secondary and tertiary amine purpose. Next, how to write this name? Alkane, E cancel, plus amine, then this is called alkanamine. But E will be present for polyamine groups. Keep in mind. More than one NH2 groups are present mean E will be present. One amine group in E cancel. That's why you remember here. Now, in this, the first one, what is it here? Numbering start from right to left because lowest number we have to give to the functional group or substituent. Therefore, it is called 2. Otherwise, you can write like this also. This is old actually first one. Butane, E cancel, 2 amine. Now here numbering 1, 2, 3, 4. Which substituent present? Methyl group. Position third. 3 methyl. Then total 4 carbon. Butane. First position amine. 1 amine. E cancel. Similarly here, on nitrogen one substituent is there. Numbering start from 1, 2, 3, 4. Then substituent present on which one? Second one. So this is called N-methyl. This is a prefix. N is a prefix present on the nitrogen methyl group is there. This methyl group present on which one? Second one. Therefore, it is known as butane 2 amine. Similarly, next one, numbering if you start from the right side to left side, 1, 2, 3, 4, 5, 6. If you start from left to right, then this nitrogen substituent carbon will get the higher number. That's why not good. So now you have to find out the substituent. At which position is there? Fourth position and second position methyl group is there. Therefore, it is 2,4 dimethyl. And next, N, N, dimethyl. These are the prefix. Then total how many carbons? 6. Hexane, which position? Third position, amine. So I hope you understood this nomenclature. Then the next question is, draw the structure of the following. The first one is tertiary butyl amine. How to draw the tertiary butyl amine? First we should know the what is a tertiary butyl. This is called tertiary butyl and this is called amine. This is tertiary butyl amine. The next one is alpha amino propionaldehyde. Prop mean what is that? 3 carbon. Therefore, this is the aldehyde group. This is functional group. Next carbon is alpha. Then alpha amino mean this is the NH2 group. Alpha amino. The next one is what do you call? 4-dimethyl aminopyridine. 4-dimethyl aminopyridine. Then pyridine structure we know first. This is the 1 minute. This is called pyridine. Then we know the numbering system. Nitrogen atom in the cyclic first number 1, 2, 3. This is a 4. This is a 5. This is a 6. This is fourth position. What is the dimethyl amine? So this is 1, 2. 2 methyl group is CH3, CH3. Next, what is that? 2-methyl aziridine. First, you should know that this aziridine structure N like this. This is aziridine. This is the first number. This is a second number. This is a third number. Then 2-methyl group. This is because nitrogen atom in the cycle that get the first number. Then E. What is the E? N-methyl, N-ethyl, 3-hexanamine. Hex mean how many carbons? 6. 2, 3, 4, 5, 6. Then which position we have? Amine group third position. Therefore, we have third position. 1, 2, 3. On that one methyl group is there. Another is ethyl group is there. Next one. Metachloroaniline. Aniline structure we know. This is a benzene on this NH2 group. This aniline. This is called 1, this is a 2, this is a 3. Third position is called meta. Therefore, 3-chloro or metachloroaniline. Next question is, give correct name for the following amines. Now the name is, numbering start from the right to left. 1, 2, 3, 4, 5. Because we have to give the least number to the functional group. Therefore, it is 5 carbon pentane. Which position? Second position amine. Pentane 2 amine. The next one 1, 2, 3, 4. This is which one? Nitrogen on this methyl group is there. Therefore, it is written as N-methyl. Total how many carbon? 4. Butane and second position amine. Next one, this is called aniline and this is called hydroxy. But hydroxy group is the first priority group than the NH2 group. Therefore, we have to give numbering 1, 2, 3. Then what you call this is 3 amino phenol. The next one, fourth one, what is the name of this one? This is actually, if it is methyl group not there, means this is called pyrrole. But we know that numbering for heterocyclic, this is 1, is a 2, is a 3, is a 4, 5. Therefore, this is called 3-methyl, 3-methyl pyrrole. In the fifth one, here NH2 group is there, and here also NH2 groups are there. But this is a nearer to the observer, this is away to the observer. These are opposite direction is there. Therefore, it is called trans to the cyclic system. And cyclic is there, therefore this is called cyclo. How many carbon? 5 carbon. Therefore, pentane. E will be retained here because polyamine group. This is 1 and 2. Diamine. So here this is a 1, this is a 2. Therefore, 1,2 diamine. The next one question is, here we have amine group, here we have aldehyde group. Therefore, aldehyde is the first priority group. Therefore, here 1, 2, 3. Which position we have? Third position amine group. But keep in mind, NH2 group and aldehyde group both are nearer to the observer, same side. Therefore, this is called cis. Position which one? Third. Amino. Cis 3 amino. Cyclohexane. Carbaldehyde. I hope I explain all the different way of nomenclature, classification, and common names and heterocyclic, aromaticity, everything include in this video. So if any doubts are there, any nomenclature related classification, you can comment me, I will answer.